Hello, everybody. Okay, so today this lesson is going to be on negative exponents. We're on Chapter 1, Lesson 5. So when we've looked at exponents before, a couple of things that we need to talk about. We need to talk about zero exponents. We need to talk about the exponent of 1. And we need to talk about negative exponents. Okay, to do this, we're going to just look at a series of exponents. So if we had 3 to the power of 3, this would be 27. 3 times 3 times 3. And 3 to the power of 2 would be 27 divided by 3 because we're taking back one of the 3's. And that would give us 3 squared, which is 9. Then 3 to the power of 1 would be 9 divided by 3, which equals 3. So if you have an exponent of 1, the exponent of 1 equals the number itself. So that's the first thing we have to accept, or we have to understand. Exponent of 1 equals the number itself. So if the base was 3, 3 to the power of 1 is 3. 10 to the power of 1 is 10. A million to the power of 1 is a million. So the exponent of 1, it's like we take it away and say 3 equals 3. A number to the power of 1 is equal to itself. Okay? The next thing we've got the zero exponent. So that would be 3 to the power of 0 in our little run here. And 3 to the power of 0 would be 3 divided by 3. 3 divided by 3 is 1. So a zero exponent equals 1. If the exponent is 0, the answer is 1. So 10 to the power of 0 equals 1. 0.001 to the power of 0 equals 1. A million to the power of 0 equals 1. So no matter how big or how small, if you put it to the power of 0, it equals 1. Now come the negative exponent. So 3, 2, 1, 0. The next thing would be negative 1. So 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. 1 divided by 3 is 1 divided by 3, or 1/3. 3 to the power of negative 2, so 0, negative 1, negative 2, would be 1/3 divided by 1/3, which would equal 1 to the power of 3 squared, or 1/9. 3 to the power of negative 3 would be 1/9 divided by 3, which means it would be 1/3 to the power of 3, and that would be 1/27. So I want you to notice when the exponents are positive, we get a whole number. When the exponents are negative, we get a fraction. So the exponent is the same number, it just becomes a fraction. So we played a little game in class called Stay or Go. So if we had a squared, b to the power of negative 2, c to the power of negative 4, and d, e to the power of 1, f to the power of negative 2, g to the power of negative 1, and h to the power of 3. If a number is happy, if it's positive, it gets to stay where it is. If it's positive in the numerator, it stays in the numerator. If it's positive in the denominator, it stays in the denominator. You have to decide if the exponent is positive or negative, and if negative, we change where it is on the fraction line. So this is a squared. A is positive, or sorry, the 2 is positive, so a squared stays where it is. B to the power of negative 2. Negative 2 means it's not in the right place. We can't have negative exponents. So in order to make this negative exponent positive, we are going to move it to the denominator where it changes signs. It changes place, it changes signs. C to the power of negative 4. That negative means we're going to move it. We're going to move C down here and make it negative 4. But now that we've moved it, we're going to change it from negative 4 to positive 4. D, you may not see the exponent, but remember it's always there. So it's d to the power of 1. It's positive, it stays. E has an exponent of 1. We are going to leave it. It's positive. F is negative, so we're going to take it from the denominator and move it up here to the numerator. G is negative. It moves from the denominator to the numerator and becomes positive. H is in the denominator and it's positive, so we're going to leave it there. So this fraction should actually be written like this: a squared d f squared g over b squared c to the fourth e h to the third. All the exponents are positive. They go from positive to negative or negative to positive when we change them on the fraction line. One of the things you're going to be asked to do is take a number that has a negative exponent and write it as a positive exponent. So you're going to take your 2 to the power of negative 3, and remember that this is 2 to the power of negative 3 over 1, and we're going to flip it over. We're going to move this down here. So this becomes 1 over 2 to the power of 3. Once we move it, it changes signs. So x to the power of negative 4 becomes 1 over x to the power of positive 4. All right? So this is how we change a negative exponent to a positive exponent. What if you have 1 over x to the power of negative 2? Well, it's negative in the denominator. We move it to the numerator and it becomes positive. So you can either write it over 1 or simply write x squared. If you are asked to write an exponent as a negative, and say you have 1 over 2 to the power of 3, and I want you to write it as a negative exponent, you're going to move it from the denominator to the numerator and change its sign. Move it from the denominator up to the numerator, change its sign. Okay? What if it was, I gave you x squared and I want you to write it as a negative exponent? You would say 1 over x to the power of negative 2. 2 to the third power as a negative would be 1 over 2 to the negative third power. Again, whenever you change its position on the fraction line, it goes from positive to negative or negative to positive. It changes. Okay? Now, why do we care about this? Well, you're going to have some times when you're going to have to multiply and divide with negative exponents. So maybe you're given something like this: 5 to the power of 3 times 5 to the power of negative 5. We know that when we have a common base, we write the base and we add the exponents. So 3 plus negative 5 would be negative 2. Well, you're not allowed to have a negative exponent. So we would have to take this, flip it over, and call it 1 over 5 squared, or 1 over 25. What if you had something like this? What if you had w to the power of negative 1 over w to the power of negative 4? Well, we can flip this over so that our signs are positive. this would become w to the power of 4 over w to the power of 1. And we know when we have fractions, we keep the base and we subtract the numbers in the exponent. So 4 minus 1 would be 3. So this would be w to the power of 3. What about if you had 11 squared over 11 to the power of 4? Well, since the 2 is smaller than the 4, we are going to take this 1 times 11 squared over 11 to the power of 4. We're going to move this from the numerator to the denominator, where it's going to become 11 to the power of negative 2. I now have 1 over 11 to the power of 4 times 11 to the power of negative 2, and I can combine my exponents. I have 4 minus 2, so this would be 1 over 11 squared. Or 4 minus 2, but since the 4 is in the denominator, it ends up with the answer in the denominator. Okay, let's try something else. What about b to the 4th over b to the 7th? Oh, wait a minute. Sorry. Let's try that again. Negative 7, negative 4. Okay, so we flip this over. That becomes b to the 4th over b to the 7th. Now we're going to subtract. Since we subtract them, 4 minus 7 would be b to the power of negative 3. But since we can't have a negative exponent, we now have to flip it over and make it 1 over b to the power of positive 3. Could we have done this a little different? Sure. We could have said 7 minus 4 is 3. There's nothing on top, so I put a 1. You could have saved yourself the 1 step, but that would be the answer. So with 0 exponent, the answer is 1. With an exponent of 1, it's the number itself. With negative exponents, you have to flip them on the fraction line to make them positive. All right? Good luck with this, and let me know if you have any questions.